Bismillah ar-Rahman ar-Rahim. So the today chapter which I am going to start is quality management. So quality management, why quality management is very, very important. So because when we producing goods or when we providing services, the quality is very, very important. Quality play a very, very important role. If the product or the services which you are going to provide to the end customer, if the quality is not good, nobody will buy it. And the competitor already exists in the market, so they will capture market from you. So at the end, your profit will be down and your losses will be going up, your cost will be going up. So as I already mentioned, that the main objective of every organization is to maximize the profit and minimize the cost. So quality play a very, very important role. How you will measure the quality, how you will check the quality of the service, how you will check the quality of the product. So in this chapter, I'm just going to show you that how we will measure, how we will use different statistical tools. So the statistical, as we already studied, that statistical applications start after the First World War in the quality management. Different quality gurus, which we have already discussed. So those quality gurus, basically after the Second World War, most of the professors related to statistics, they start work on the quality in order to rebuild, reshape the Japanese production sector, reshape the industrial sector of the Japan. So they start work and they use different statistical tools in order to upgrade, in order to measure the quality, in order to upgrade the quality of their product and the quality of their services. So that is why now the Japanese product in the whole world are considered the best product, or the services which they provide are considered the best one. So what are these statistical quality control tools? So in this chapter, I'm just going to discuss those statistical quality controls. So most of those statistical things you already studied in your undergrad, in your different courses. So now in this chapter, I'm just going to show you that how you will use those statistical quality controls, statistical tools. So definitely we will be using some descriptive tools, we will be using some inferential tools. So most of you people know that there are two types of statistic. One is descriptive statistic and the other is the inferential statistic. So we will use these statistical tools in this chapter. So there are three statistical quality control categories. Statistical quality control is the term used to describe the set of statistical tools used by the quality professionals. So as I already mentioned, the quality gurus, which they use in order to improve, in order to further refine the quality of a product or services. So these are the three defined in the three broad categories: the descriptive statistics, statistical process control, acceptance sampling. So descriptive statistic is the basic things, the basic concept of statistic which we already know normal in our daily life. We also use these descriptive statistic, for example the mean. So why mean will be considered as a statistical quality control tool? Because normally in our daily life we also use mean, because in every exam you people asking what is the average, what is the average grade. So basically this average grade, then after that you compare yourself with that mean, that you are near the mean, you above the mean, or you below the mean, above the average, below the average. So basically this is an indicator, this is just a measure which show you that this is the mean. For example, if you producing some specific product while using different machine, so on the daily basis you also produce some defective product. So how you will check, for example, in 1 month, what is the mean of defective? So if this mean value is very high, their production will be considered as not so good. If this mean is very low of the defective part, it will be considered as a good production. Similarly, the second descriptive statistic tool which we normally use while measuring the quality is the standard deviation. So standard deviation, basically standard deviation, it is clear from the name, deviation from where? Deviation from the mean. How much the process of your experiment, how much is deviate from the mean. So for example, the mean grade in your class, let's suppose is in the 25 marks, the mean marks are 15. Now a specific individual student, how much it deviate in the positive side and how much it deviate into the negative side. So if the dispersion, if the spread, normally in the normal distribution we have already studied, if the spread is too much, this is not a good sign. But the spread, if it is near the mean, this is considered as a good experiment. So standard deviation basically showing you the spread, the visualization of the mean and how much it deviates, the specific intervals, how much it deviates from the mean. So basically it's showing us the spread, the dispersion from the mean. And range is also a very simple tool which showing you, for example, if you're going into a shop, you ask from the shopkeeper that please tell me the range. Range means what is the lowest price and what is the highest price of a specific company product. So when he or she tell you, then after that you start thinking, then after that you start deciding that which type of product at which price should I need to buy. So range, the definition of range is the difference between highest and the lowest observation is called range. So I will discuss this in great details, but in the first instant I am just going to define these things that in order to recall you the concept of these specific tools. Statistical process controls. This is the second category which involves inspecting the output from a process. Quality characteristic are measured and charted, helpful in identifying in process variation. So in the statistical process control, we will construct a process control, we will construct a boundary, then we will check that our observation are inside the boundary, inside the feasible region, or it going outside the region. So we will basically construct some specific lines, some specific boundaries that our observation, for example, if you display a scatter plot, if you insert a scatter plot in the Excel, then you already define some specific zone, some specific boundary, some specific feasible region. Then you check which specific point, which specific observation is outside that boundary, is outside from that feasible region. So basically statistical process control give us help that which specific observation is out of the boundary, and then on the basis of that statistical process control, we will decide that these observations are outside the boundary. So we should need to rethink, we should need to redesign, we should need to reprocess the whole process in order to bring those outside, those observations which are outside the boundary, in order to bring it back into the feasible region. Acceptance sampling used to randomly inspect a batch of goods to determine acceptance or rejection. So in the hypothesis testing, which we have already discussed in the earlier lectures, in the earlier courses, that how you will accept and how you will reject. So normally we need to calculate p-value. If p-value is greater than the level of significance, then we accept null hypothesis. If it is less than the level of significance, then we reject the null hypothesis. And you also know that we need to calculate F statistic, chi-square statistic, student T distribution, Z distribution, analysis of variances, etc., etc. Even also in the multilinear regression, we have already discussed, in order to calculate correlation, coefficient of determination, should we need to overall accept the sample or should we need to reject the sample individually. You also know for each specific dependent and independent variable, we also draw a random statistic test in order to check that specific dependent and independent variable are accepted or rejected. So you can also use acceptance sampling, which randomly inspect a batch of good to determine accept or reject. For example, if you want to buy a whole container of old mobile phone, you randomly select some mobile phone and you inspect, and then on the basis of that results, if you need to conduct a hypothesis testing. If your hypothesis testing lies, if your result lies in the accepted region, you will accept that whole container, you will buy it. If the sample analysis of the data, if it is fall in the rejected region, on the basis of that, you will say, I don't want to buy this whole container because the analysis show me that this is in the rejected region. So that is why we will decide we not need to go to buy that whole container. So these are the basic three statistical quality control categories. So we will discuss in this chapter, in these lectures, these two, descriptive statistics and statistical process control, and we have already covered this, and if you want, we can also discuss that in the interactive session. So normally when we collect data, the most important thing is the collection of data. If it is related to production, if it is related to services, if it is related to some disaster, so the most important thing, you need to collect a refined data. Then we need to start check the behavior of the data. What kind of data is it? Is it some seasonal data? Is there some trend involved in the data? Is there some cycle involved in the data? Or there are some irregular fluctuation involved in the data? So we know that in the data there will be some specific form of variation exists. Variation exists in all processes. Even in this whole nature, variation exists. Even in our life, variation exists. Without variation, nothing will happen. So if variation removing from the life, if variation removing from the data, if variation removing from the processes, so that will not be, that will be 100% correct. So nothing is 100% accurate. Okay. So variation exists in all processes. Variation can be categorized as either common or random causes of variation. So as I already mentioned to you, just like in the multilinear regression and the causal model, we have already studied that variation will be, sometime it will be exogenous or sometime it will be endogenous. Exogenous means that something will affect a specific variable from the outside. For example, a company production, maybe some outside, just like we already studied in the SWOT analysis, strength, weaknesses, threats and opportunities. So threats and opportunities are from the external side and strength and weaknesses are inside things. So maybe our production or a specific company production will be affecting the outside factors and maybe sometime it will be affecting by the inside factor. So common or random causes of variation are random causes that we cannot identify. So normally also something happen which we will not be able to identify, which we will not be able to see it with the naked eye. Unavoidable, and we will not be able to avoid it, because if we avoid it in the future, it will create a lot of problems. So for example, slight difference in process variable like diameter, weight, service time, temperature. For example, the Pell refrigerator company, they are producing refrigerator air condition. So maybe they will try their level best to improve the quality, but maybe there will be some minute differences occur. Sometimes people return the product of a specific company. Let's suppose you buy an Apple iPhone, but you face some problem. Then what you will do? You will return it. Normally it happens. So basically some variation occur in the production, or sometimes if you visiting to a good restaurant which is very famous for their services, so maybe some random, due to some random situation, due to some random accident, maybe you will not like the services of the staff of that hotel. So slight difference in process variable like diameter, weight, service time, temperature, these things are occur all the time. Now the thing is how to remove these variation. Not 100%, but at least 99%. So we will be able in order to identify those variation, and then in the future how to remove those variation, we need to study some statistical tools. After that we will be able to apply those tools, so in order to remove these variation. Then assignable causes of variation. What are the main factor, what are the main causes due to which the variation occur in the process, in the production, in the service quality? So causes can be identified and eliminated. So causes, why? Due to the electric shutdown, due to the low voltage, due to the raw material. Why the product is not that good? As it is defined in the start that this will be our product in the design stage. So causes can be identified and eliminated. So how you can identify and eliminate? You will get feedback from the customer. Normally on every product they mention the feedback that if you have some specific problem while using this product, if you have some specific complaint, then just tell us on this number. So causes can be identified and eliminated. So this way you can collect data, and then in the future production you can eliminate those errors. For example, poor employment training, worn tools, machine needing repair. So all these things, these example, you can check, you can identify it, and you will be able to eliminate all these things. So traditional statistical tool, as I already mentioned to you, the descriptive statistic include, these are the descriptive statistic main pillars: mean, measure of central tendency, which give you the average, the range, difference between the largest smallest observation in a set of data. So for example, the mean, the formulation of mean is x bar, is equal to summation xi divided by n. So basically these are the observation. The observation, let's suppose if I collect the number of, let's suppose if you producing pizzas, so on the daily basis you produce 3 defective pizzas. So if I just get this, that normally on the daily basis the number of pizzas, 3 defective pizzas. On Monday, let's suppose on Monday there was 3 defective pizza, defective. Okay, on Tuesday it was 2, on Wednesday it was 1, on Thursday 3, on Friday 4. So when you sum it, 4 plus 3, 7, 8, 9, 10, 11, 12, 13. So 13 and 1, 2, 3, 4, 5. So x bar will be summation x by n. So these are the x observation, the defective pizzas. So summation x 13 by 5, because how many observation? 1, 2, 3, 4, 5, because in the observation you only consider the 5-day data. So it will be 6.5. So the mean of the defective pizza will be 6.5. So basically this means showing you a specific average. If this average is going up, it will not be a good sign. But if this average is going down for the next 5 days, this will be considered as a good. You improving, you removing the error, you removing your production, you removing your service. So this is basically give you an indicator. So the mean measure of frontal tendency showing you a specific, this is an indicator. So while taking this, while improving this will be reduced, and when the values is reduced, your quality will be automatically going up. The range difference between largest smallest observation in a set of data. So as I already mentioned, range basically show you that this is the peak and this is the lowest level. So when you understand the lower bound and upper bound, you will be able to conduct, you will be able to check the dispersion, you will be able to remove, you will be able to reduce those dispersion, those deviation from the mean. Standard deviation, so as I already mentioned, which measure the amount of data of dispersion around mean, that how much it deviates from the mean. So let's suppose if this is the mean, this is the mean, okay, so it lie over there. This is the mean, let's suppose mean is 3.5, and in this case the mean is this one. So in this case mean is, the dispersion is very high. In this case let's suppose mean is 1.5. So definitely in this case mean will be 2.5, because there is too much dispersion from the mean. So this is not a good sign. When the dispersion, when the standard deviation value is low, it's near the mean, then it will be considered as its mean, the dispersion will be very low, then it will be considered as a good quality product. If you collect data just like we did collect data in this example, so when the standard deviation is very low, its mean, the deviation from the mean is not too much, so it will be considered as a good measure quality. Distribution of data shape. So as I already mentioned to you, normally we will sketch the data. How does it look like? So in the normal distribution, you also know it's a bell-shaped curve, just like we already tried. In the normal shape, we draw this. This is a normal, this is a bell-shaped curve. Mean, median and mode lie at the same point in the normal distribution. So this is the characteristic. It is a bell-shaped curve and it is a symmetric distribution. So then we also need to check the behavior of the data while distributing the data shape. So the data shape will also tell us if it is look like this, then it is called rightly skewed, positive skewed. Okay, so when we collect data and when we sketch it, we will be able to define the deviation. This is negative skewed, negative skewed. So we can check the behavior of the data while plotting it, while checking the shape. That is it a positively skewed? Is it a negatively skewed? Is it platycartic? Is it mesocartic? Or is it symmetric distribution? So basically, while using the statistic, while using this standard deviation, and the formula of standard deviation is summation xi minus x bar whole square divided by n minus 1 and taking the square root. So standard deviation is while when you take the square root of variance, you will calculate standard deviation. So how you will calculate this? So let's suppose this is my, in the example which I already discussed, this is my x. Okay, so we have already calculated. In the next column, what you will do? Xi minus x bar. So 3 minus 6.5, 2 minus 6.5, 1 minus 6.5, and you will calculate this. At the end, you will calculate summation xi minus x bar whole square. So in the next column, you need to take the square. You also need to take the square. So when you take the square, when you divide, so n is 5, 5 minus 1, and when you take the square root, so you will get this standard deviation. So basically these tools, these are very simple tools, but these tools normally we studying in every class, but actually these tools play a very important role. It will tell you the behavior of the data. The data, you collect data related to some problem, you collect data related to some processes, so it will tell you basically the behavior of that data. So you can see from this slide the distribution of data. This is normal distribution. So as I already showed you in the previous slide, this is large standard deviation, but this one have a very small standard deviation. The mean of both lie at the same place. Mean of this and mean of this lie at the same place, but the dispersion is very high. So this dispersion is not good in the data. Okay, so if we want to check the quality, this quality will be good as compared to this one. Skewed distribution, as I already mentioned to you, this is symmetric. Symmetric means the mean, median, and mode lie at the same point, while in the symmetric, in the non-symmetric, in the skewed distribution, it will be a positively skewed. This is a negative skewed. Negative skewed means the left tail is going longer. It never touched the asymptote, but it's going longer. In the positive skewed, the right tail is going longer as compared to the left tail. So as I already show you, so basically these things will show you the data behavior. The data, when you visualize the data, it will tell you the behavior of the data. So statistical process control chart shows sample data plotted on graph with CL means central line, upper central line, and lower central line. So basically in the statistical process control, we will use the descriptive statistic, for example mean, median, mode, or percentages, etc. in order to construct this central line, upper central line, and lower central line. So for example, my central line mean just like in the previous slide, 16.0 is my mean. So this is my central line. So in order to calculate, in order to check the observation, for example in the previous example I have discussed some defective. So in order to check that are these date, because from Monday to Friday we producing different pizzas and we have different defective pizzas. So we will check that which observation is outside from the upper control and which observation is inside the upper and lower control. So this is lower bound and this is upper bound. So control chart shows sample data plotted on a graph with central line, upper central line, and lower central line. Control chart for variable are used to monitor characteristic that can be measured, for example length, weight, diameter, time. So basically it depends on it. If you collect data of length, if you collect data of weight, if you collect data of time or diameter, so you can easily visualize it and you can easily check that which observation are inside in the control and which observation are out of control. So control chart for attribute are used to monitor characteristics that have discrete value and can be counted. For example, % of defective, number of flaws in a shirt, number of broken eggs in a box, number of accident in on motorways, number of air crashes, number of defective in production, number of absentees, etc., etc. So basically this is also a visualization of the data. Just like in the previous, I show you that normal distribution, if it is rightly skewed, if it is negatively skewed, if the standard deviation is very high and if the standard deviation is very low. So basically from visualization of the data, you will interpret your result, that what is the behavior of the data. Setting control limits. So percentage of values under normal curve. So normally I will also discuss that in you, that how much area lies between first standard deviation, second standard deviation, and third standard deviation. So if you have a look, so between +3 standard deviation and -3 standard deviation, 99.74% area lies, and the remaining are 1 minus 99 minus 0.74%. Between +2 standard and -2 standard, 95.44%. And between 1 sigma and -1 sigma, it is 77% approximately.